All right, class, my expectation is that you will listen to this video that I'm about to do, and that you will copy down on your study guide the things that I've put here, and that you'll probably need to pause it periodically to make sure you get things written down. But here we've got a quadratic in standard form. Obviously, it's going to open up because it's a positive leading coefficient. The vertex, we have to use the vertex formula. X is negative b over 2a. And then once you get that x value, then you go back and you plug it in wherever there is an x. And the left side, this says h of x, but it stands for the y value. It turns out when you plug it in here and here, the y value then is negative 6. The axis always goes through the x value, the vertex, so it's x equals negative 2. The y-intercept is always picked up with standard form at that last number. So this is a negative 2, but keeping it as an ordered pair, it's 0 on the x coordinates and a negative 2 on the y-axis. Now the x-intercepts are harder to get with this. What you have to do is to plug a 0 in the place of the y, and you may want to remember that the x-intercept always looks like that. So in this case, we get a situation to solve this quadratic, only it doesn't factor, so we have to use the quadratic formula as you see here. And you end up with this radical answer, which is nice algebraically, but it doesn't help us graph. So you have to change that to a decimal form in your calculator. And you can see that the x-intercepts are here and here. The domain is all the x values represented there, which would be from all real numbers, negative infinity to positive infinity. And then the range would represent the y values. So the y values start down here at negative 6, and then they go up forever in terms of that curve. All right, the second one is in vertex form. So the vertexes would be negative 2, 2. It's the opposite of what's in the parentheses. The axis again goes through the negative 2 on the x coordinate. The y-intercept, and just ignore this scribbled mess over here. The y-intercept you get from putting a 0 in the x spot. It may help you to remember that the y-intercept always looks like that, where you've got a 0 in the y. And so when you plug that 0 in, then you get that y is equal to 6. The x-intercepts, you have to put a 0 where the y is, and then solve for x. We subtract 2 from both sides, then take the square root of both sides, but taking the square root of a negative 2 would be the square root of negative 1 times the square root of positive 2, and the square root of negative 1 is I. So it's plus or minus I onto the square root of 2, and then finally we subtract that 2 from both sides, and that's where we get those x-intercepts. The domain, again, is all real numbers. The range, it starts at positive 2, and it goes up forever. Notice there are no x-intercepts because the two solutions here represent imaginary numbers. It never actually crosses the x-axis. All right, let's turn the page then. And number 3, we're told that 3, 6 is a point on some function f of x. So I've graphed it here. Now, if you hit it with this transformation, x minus 3 minus 4, that means you're going to go right 3 and down 4. Well, where do you end up from here? If you go right 3 units and you're already at positive 3, right 3 means you're at 6, and you come down 4. If you were at 6, you're down here at negative 2. So 4, 2 would be the new location. Number 4, true or false? Is this a vertex of 3, 0? Yes, because you could write it as plus 0. And remember, the The x value is always the opposite of what you've got inside the parentheses. All right, number 5, you've got two functions, one f of x, that's this one here, one g of x. The f of x function is at -4, -3, that's the vertex. The g of x function was at +2, +1, right there. So how do you go from here to here? Well, you're at -4 over to +2, that's right 6 units. And once you're here, you're going from, where are we, -3 up to +1. So from -3 to +1 is up 4. All right, number 6, the horizontal distance between the vertices. Well, again, you have to find the vertex of this one. This one's easy. The vertex is -3, 5. This one, however, you have to change to vertex form. So we do that by completing the square. We move that -4 over here to the right, put in a new perfect square term. We take that b number and divide it by 2. We do the shortcut of factoring, and then we got 4 plus 9 is 13. Okay, now we want to get the 13 back over here so that it looks like vertex form. So we subtract 13. And so the final vertex here is -3, -13. Well, this one was -3, 5. So in terms of a horizontal difference, they don't move at all. The x value is the same, -3. So there is no horizontal distance. No difference at all. So we'd say 0 spaces. All right, let's go to the next page. All right, number 7. You're comparing two functions. Function A is represented here in this table. Function B is this little slope-intercept equation. And we're being asked to find out, well, how far apart are the y-intercepts? Well, you look at the table, and you're looking for an ordered pair that has a 0 for the x, because that means that's the y-intercept. All right, that one's that right there. 0, 3. This one is, the 9 is the y-intercept, 0, 9. All right, well, how far is it from 3 to 9? Well, that's where you get 6 units. All right, number 8. What is the intersection of these two functions, y sub 1 and y sub 2? Well, an intersection means they have the same ordered pair, don't they? So you're looking for the ones that have the 2, 3, 2, 3. And so those would be, that's the intersection. All right, and number 9, I've sketched it out, but really you want to do this in the graphing calculator. Put this under y sub 1, this under y sub 2, and find the intersection. Now it turns out that it only touches at one spot, and you do the intersection program. You go second calc, number 5, intersect, and hit enter 3 times. You get 0, 2. All right, now number 10. What's the vertex of this? Again, this should be easy by now, -5, -3. And we're taking that same one now and we're putting it in standard form. Well, to do that, you need to know that x plus 5 squared is x plus 5 times x plus 5. So first we do the distributive property, not forgetting that we'll take away 3 from it when we're all done. So we got x squared plus 5x plus 5x plus 25, take away 3, and when you're all done, you combining and you get x squared plus 10x minus 22. All right, last page. Number 12, you're asked to do a linear regression, or no, excuse me, a quadratic regression. And you're just going to have to remember the steps. You go to stat, list 1, you put the x's, the m values in list 1, the s values in list 2, and you go through that whole process of a regression, and then you have to round it off. And that's what you would round it off to. But to find what happens in month 11, notice that the table didn't include month 11, so you go look at the table in your calculator, and it turns out that when x is 11, the 11th month, you read across, and y is 30.56. All right, now number 13 is a word problem that deals with the company profit. The question that counts is how long will it take for it to break even, meaning that they are above zero. See, this is profit here, and this is time. So when you graph it, the break-even point is that intersection right there. That's where time is zero and the profit is zero. So anything to the right, they're starting to make some money. Well, how long is that? Well, you put it in the y equals menu and find the intersection, and it turns out to be about 4.1 years. All right, number 14, another business model, modeling the profit, but how much should the company charge each item, X? So here we've got, again, profit, and here we have, well, let me write that, profit, and here we have dollars per unit. Now, to get this, I had to resize the window. I put that in the y equals menu. I changed the window to x max of 50, a y max of 1500. You're just going to have to play around with it. And you go to the second calc and you do that max program. You'll go to the left side, to the right side, and then you hit enter a third time. And so when x is $13.60, they're making their highest profit of $1,289. And so that would be the answer there. Now, when you get home tonight, this video will still be there, and you're welcome to use it as often as you want, and I sure hope it'll help. Have a good one.